We are in section 1.5, multiplying integers. Something we've talked a little bit about, but this is the section just all about multiplying integers. So integers we talked about yesterday fall where on number line? Where are the integers? You remember without looking at the definition? Integers, Mark.
Integers are positive and negative numbers, including zero.
Including zero, and not any fractional pieces. So it's the definition we used was the positive whole numbers and their opposites. Shortest way to say it, as long as you know what those things are. Okay, so no whole numbers include zero, right? So whole numbers and their opposites. So when we multiply integers, we have different kinds that we could be multiplying. Anytime we multiply by zero, what is the product?
Zero.
So that one we don't talk as much about. That is called the multiplication property of zero. So there is a name for that. Can you say that? Multiplication property of zero. Okay. It's more interesting when we're multiplying positives and negatives and various combinations, right? So the first question is, I'm not hooked up, just 1 second. Okay, so the first, what if we're multiplying two factors with the same sign? So the signs could both be, let's say, positive. Here's an example. Let me just jot one down up here. Give me a number, Chuck.
Just any number?
Yeah.
10.
10 times, let's say, 3. Those are both positive. See, they have no negatives in front of them. 10 times 3 is 30. So you know that the product there, is it positive or negative? Positive. How about if we take a couple of negative numbers? Michael, give me a couple numbers that are both negative.
Negative 3 and negative 10.
Negative 3, oh, well, he's making this easy. Same numbers we just used. So negative 3 times negative 10 is?
Negative 30.
It's still 30. It's
Oh, right,
still
yeah.
positive. So our first rule states that when you have factors that are the same sign, two factors of the same sign give you a positive product. Even if you have two negative factors, it gives you a positive product. So is that true if I have three negatives?
Yes.
Would I have a positive product still?
Yes.
Okay, let's try it.
No.
Let's try it. Let me just make a clean sheet for a second. And let's just use 1 because it's such an easy factor. Negative 1 times negative 1 equals what?
One.
It equals a positive 1, right? So let's try this. Negative 1 times negative 1 and add another 1, negative 1. And so we have negative 1 times negative 1, which is 1. And then we have 1 times the negative 1, which is?
Negative 1.
So this whole thing is negative 1. See that? Now what if I add another negative in front of it? Negative 1 times negative 1 times negative 1 times negative 1. What do we have now? And to prove it, what is negative 1 times negative 1?
1.
And what is negative 1 times negative 1? 1. And I'm grouping, so what property is that? Associative. Everyone say it. Associative. I did not move anything. I just simply grouped them. And I can see 1 times 1, which I know is a positive, right? So having done a few of these, how will I know when my product is positive? If there are negative factors there, how will I know when my product is positive? Adrian. Excellent. An even number of negative factors, right? If there are, as we see here, if there are 2 negative factors, we get a positive product. If there are 4 negative factors, we get a positive product. And then we could imagine 6, 8, whatever. Okay? So when we have an even number of negative factors, we end up with a positive product. And there's another example. If you already wrote the 10 times 3 example, you don't need to write this one. If you haven't put an example, let's finish this one. Go ahead and quietly finish it. Skylar, 7 times 3 is? And what is it? Negative 7 times negative 3? Also 21. They're both 21. Good. Okay, so there we have 2 factors with the same sign. Now 2 factors with different signs. So let's think about the numbers we were working with above. 10 times 3. Let's make one of those negative. And so if I have 10 times negative 3, what now is the product, everyone? Everyone? Negative 30. So rather than being 30, we have the opposite of 30. We have one negative, right? If that was positive, we would have a product 30. But it's negative, so we have the opposite of 30. We have negative 30. When we have different signs, we end up with, if there are simply two factors, then we'll end up with a negative product. Good. And as we saw over here, let's add another example up above. 1 times negative 1. So 1 times negative 1 is? Negative 1. It goes right along with what we were just saying, right? Here is one negative factor. Here are two negative factors. We see that this one turned out to be a positive, right? Here are three negative factors, and what do we get here? A negative. This one was negative, this one's negative. When would you expect to see the next negative product? With how many negative factors? 5, right. So you're now saying that as long as you have what type, how many negative factors will give you a negative product? An odd number, right? An odd number. Thank you for raising your hand, you who are raising it. There you go, odd. And there's another example. Okay, so we have negative 24 when we multiply those together. Don't forget your order of operations when you are facing your questions regarding multiplication, okay? And we're going to try these. We're going to bring some people up to try them. So if you're at home, pause the video, come back and check. You'll see what they came up with. Okay, so we have number 5, we see was expanded to show negative 2 is happening twice because the negative 2 is in parentheses. And so this whole factor is happening twice, that exponent says. So this is correct. Number 6, negative 2 is not in parentheses anymore. So what factor is happening twice? You know, Emma? What factor is really happening twice, Kyle?
2.
Just the 2. So this is not actually accurate, expanding it that way. You would actually need to show negative, and then we have what's going on here is 2 times 2. That exponent, I know this is tricky, it looks like such an easy little expression, but that exponent is only affecting the base that's right next to it. And that negative is like a separate number to the left of the base. If this was in parentheses, this would just be exactly like number 5. And the answer would be 4. But it's not. So instead, it's like saying, I have negative 1 times a 2 squared. We could even put a 1 out there. Negative 1 times a 2 squared. So the product is negative 4 here. It's different than number 5. So knowing that now, how about number 7? How can you expand it? Kayla, you're going to come up and do it. Very good. So in number 7, we are supposed to take the opposite of 4 times 4 times 4, right? Which is negative 64. And now, how can we expand, just tell me from your seat, how do we expand number 8? Jensen?
Negative 4 times negative 4 times negative 4, and then I did negative 4 times negative 4 is 8.
It's actually 16.
I mean,
Look
16.
We're right back to this one, aren't we? So the product is going to be 64, and is it going to be positive or negative? Thumbs up if you agree. She said positive. And who says negative? Okay, you can vote once. Who says positive? Raise your hand. Who says negative? And you're right, it's negative. Negative times a negative is a positive. And then you multiply by negative, and there you go. Your product is negative. There were 3 negative factors. Okay? Check your work so carefully today, where you can, those odd ones, so you can catch these little errors, because these expressions look very straightforward and simple, but there's a lot of number sense behind them, okay? Multiplication properties are like our addition properties. What happens when I multiply any number by 0?
0.
I get 0. So 2 times 0 is
0.
0. This is called the multiplication property of
0.
0.
0.
Pretty straightforward. It tells us that whenever we multiply a number in 0, the product is 0, like you said. Who could give us that in the form of a rule using variables? Mark.
A times 0 equals 0.
Good job. Excellent thinking. That's it. A times 0 equals 0. When we make rules, we use the letters A, B, and C typically. And in this case, we only needed one variable. What happens when we multiply a number by 1? We get the same number, right? So in this case, 4,000 times 1 is 4,000. The number stayed the same. So shh, don't say it. But I know you're thinking about how we saw a similar property in our addition properties, right? So what do you call that property where when you operate on the number, it stayed the same? Cooper. Good, it maintained its identity. This is the identity property of multiplication. How does a number stay the same with addition? Did we add 1 to the number?
Add 0.
Add 0, right. So product of a number and 1 is the number. And who could give us this in the form of a rule? Now, Luca.
A times 1 equals A.
Good job. A times 1 equals A. And the last property is the least talked about, just as we had with addition. We had this one as well. And so I'm sure you can tell me the product. 4 times 5 is
20.
20. That's just just a statement. 4 times 5 is 20. What do we call it when we multiply two numbers together and you get a number there? Sophia. Good. Closure property. This is not open to different solutions or anything. 4 times 5 will forever equal 20. When your children learn multiplication, they will learn that 4 times 5 is 20. And your great-grandparents, when they learned multiplication, they learned that 4 times 5 was 20. It will always be. Close the door on that one. Closure property of multiplication. The product of integers equals a real integer. And now who can give us this in the form of a rule? Come on.
A times B equals C.
Good. A times B equals C, kind of like the addition one we saw. Back when I was little, they had a game called Name That Tune, and a person would say, I can name that tune in just 3 notes. And then the opponent would say, well, I can name that tune in 2 notes. And they would literally play just 2 or 3. I think Apple put it on their iPhones a while back. Anybody ever have that on your phone where you could go under iTunes and you could try to name a tune from your music bank, from your library of music, and you could name it a minimal number of tunes. You'll have to see if you have that on, if you happen to have an iDevice. But, okay, name that property. Let's see, without writing it down, if you can look at this expression and name the property that it is representing. Ready? Let's see how fast. Hand up when you have it. Actually, go ahead and shout it out when you have it. Not too loud now. Not too loud. Ready? Name that property. And
0. 0.
there it is. Multiplication property 0. Hard to say. Very good. And name that property.
Identity.
Good job. Back row got that one. That was identity. And name that property.
Closure. 0.
Oh, 0's good. You thought it was going to be the other one, right? And last one?
Identity.
Closure's not even there. Actually, could they all be closure? I suppose they could be. Okay, and that's it for that game. Have a good day.